slide. And I'm going to start by motivating Python a little bit. So one question is, why programming? I know some folks in this room come from other disciplines. They're scientists, they're entrepreneurs, they're musicians, other good stuff. Why is programming useful to you? And then also, why Python specifically? I won't argue about why programming is useful. Hopefully that's clear to all of you. But fundamentally, we live in a world in 2013 where we're surrounded by data. And you want the ability to access and manipulate data to be sort of the most empowered citizens in society, regardless of your field. So programming is great. Why Python? I use Python every day at work. These folks use Python every day at work. I love Python for a lot of reasons. One is that it's a very versatile language. You can use Python to do almost anything. If you want to analyze data, if you want to build websites, if you want to maintain your servers, if you want to make art or music, you can do all of those things with Python. Because it's a versatile language, employers love Python. So if you know Python, people definitely will want to hire you. So that's another great reason to learn Python. Python is a great teaching language. As you'll see, it reads very much like English. It has low syntactic overhead, and it's very easy to get useful work done quickly in Python. For that reason, a lot of educational institutions are switching to Python. So for example, MIT, in the last couple of years, switched all of its sort of intro programming topics over to Python, as are many other schools. So Python's great for a lot of reasons. And to give you some examples of what you can do with Python. So one thing that Python is really good for is for building websites. And there's a very popular web framework called Django that you may have heard of. And there are several talks on Django here at Pycon that are all about this web framework. And so for example, who uses Instagram? Yeah, maybe? But yeah, some guilty looks. OK, Instagram runs on Django, runs on Python. If anyone uses Firefox, Mozilla's website is built in Django. For some more guilty looks, any Pinterest users? Yeah, OK, so Pinterest is built on Django, so it uses Python. So you can absolutely build websites in Python. That is one great strength of the language. Another thing that Python is really good for is for data analysis and for graphing and for visualizations. There's a very popular library, and a library is just sort of a set of Python tools for graphing called matplotlib in Python. Who uses Excel at work? Do you kind of hate Excel? Okay, it's a little bit limited, can't deal with a lot of data. You sort of have to do what Excel wants you to do. Imagine Excel, but where you can customize everything, and you can handle as much data as you want. That's sort of what matplotlib gives you. So here are some examples of things you can build in matplotlib. So you do sort of all kinds of graphs. Your pie charts, 3D graphs. You can even, and this is kind of crazy, you can even make movies in matplotlib. Let's see if I have some examples of this. So I don't know what this would be a movie graph of, but it definitely looks cool. This is all done in Python, and not that much code. 3D animated graphs. You've got your physics simulations. And then do we have any scientists in the room? Yeah? Great. So scientists love Python. And one of the popular molecule visualizing tools, PyMol, uses Python, and you can write scripts to automate sweet rotations of your molecules in Python, all in Python. So I think that's pretty neat. You can write games in Python. So there's a very popular library called Pygame for writing games. If you've ever heard of a game called Frets on Fire, which is like an open source Guitar Hero clone, that's all done in Python using Pygame. And then for the musicians among us, there's this thing called the Echo Nest API. And the Echo Nest folks have written a bunch of stuff for analyzing music. So here's one kind of funny example of that. I think the audio guys are going to hate me for this. But what you're looking at here is using Python to cut up music into snippets. This is Bohemian Rhapsody by Queen, cut up into snippets. And you can manipulate those snippets using this echo nest library in Python. So for example, we can rearrange things, and then we can play it. Oh, I think you can't hear it that well. Maybe if they're yelling at me at the back of the room. They're like, why are you doing this? Let's see, let's do reverse sort. I was thinking. Anyway, you can't really hear us, sorry. The point, though, is that if you've ever wanted to make music or manipulate music in Python, you can do all of this stuff. So using the Echo Nest API. OK, so that's a little bit of motivation about why Python is cool. You can use it to build almost anything. Given all of that, does anyone have any questions, first off, about whether you could actually use Python in your day-to-day lives? No, you're pretty convinced? OK, great. OK, so let's go back to our outline, and we're going to get started with actual sort of learning the language. For folks who trickled in, if you could just quickly snatch that URL and follow the instructions. I can give you like 10 seconds for that. And then if folks who trickle in, if you need help, we have some volunteers up front. Just raise your hand, and they'll help you get set up. All right, so here's our introduction. Interactive lecture. So we're going to do two types of stuff here in this tutorial. One is that we're going to type out Python code that does useful stuff together interactively. So when I'm typing up here, you should also be typing along with me. And we'll have some examples of this in a second. And then the second part of this tutorial is we have some custom online practice problems using Code Academy that we wrote just for you to continue practicing online through this tutorial. OK, but let's get started. So can everyone start Python? Which, if you follow those instructions, you should know how to do. If you need help, just raise your hand, and we'll help you get set up. But the way that I start Python on a Mac looks like this. I open up a terminal, and I type Python, and I hit enter. So can everyone get to the point where they see this Python, this caret, caret, caret thing? That caret, caret, caret thing is called a Python prompt. And right here, we are at the interactive Python interpreter. So raise your hand if you are not able to get that on your screen. OK, so the first thing that, hey, Deb, scoot your body over a little bit. OK, so the first thing to know about Python is that if you ever need a calculator, Python makes a great calculator. And it's just like how it works in math class. So type along with me at this interactive Python interpreter. You can do basic math with Python. So like 2 plus 2 does what you'd expect. You could say, 1.5 plus 2.5. Subtraction works like you'd expect. Multiplication. With multiplication, use a star. So Python is a good calculator. Although I do have a trick for you. Let's check this out. Let's do some division at our Python prompt. OK, so 4 divided by 2. So far, so good. How about 1 divided by 2? This is cut off a little bit. OK, 1 divided by 2 is 0. OK, so first deviation from our normal calculators. 1 divided by 2 equals 0. What is going on here? Well, a funny thing is going on that we need to know about in Python. There are two types of numbers. There are numbers that know about the decimal place, and there are numbers that don't. So 1 and 2 don't know about the decimal place. And when you do math manipulation on them, they only can produce results that don't know about the decimal place. So when you think about it, 1 divided by 2 rounds down to 0, right? So what if we did that division with numbers that know about the decimal place, or at least one of the numbers knows about the decimal place? So that produces the result that we expect. So right here, just talking about doing math in Python, we see that we have two sort of types of things we can manipulate in Python. I'll call these two data types in Python. There are numbers that don't know about the decimal place, called integers. And there are numbers that do know about the decimal place, called floats. So two data types so far, integers and floats. And everyone should have a handout that you can sort of broadly follow along with and take notes on as we cover this material. Another thing to know is that the white space doesn't matter here. So I was able to do 4 minus 2, and I could also do 4 minus 2 this way. And Python doesn't care. In general, Python doesn't care about that kind of white space. Another thing you can do, harkening back to math class, is you can assign values to variables so that you can use those variables to represent the values as you do computation. So for example, no bad flashbacks, but think back to math class. You can do stuff like x equals 4. So this is an assignment. X equals 4 says x is now a pointer to this integer value 4. And we can use x now in mathematical expressions. So for example, I could say 2 times x, or x minus 3. What names can you give to variables? You have a lot of options. So here are a couple of examples of valid variable names you can use. So I could say magic number equals 1500. I could say cups of flour equals 3. In general, variables can be whatever you want as long as they start with a letter and they don't have any spaces.
So if you leave the spaces out, it won't parse properly, or?
So Python doesn't care about white space. So I could have left out the spaces if I wanted. I could have said magic number equals 1500, and that's also fine.
All right.
And you should, folks, definitely do what he did. Feel free to shout out if you have questions or things you want to know about, or raise your hand.
Magic space number equals, so that variable has spaces if one string.
Yeah, exactly. So no spaces in your variable names. But these are all valid variable names, and these are all assignments. OK, so let's assign some variables. Remember, type along with me. Let's assign some variables and do some more math with them. So we could say, OK, eggs per cake equals 3. And maybe we're preparing for a wedding, so we need to make a bunch of cakes. Number of cakes equals 10. So what is the total number of eggs that we would need? Now this math is easy, but doing it using variables, we would say eggs per cake times number of cakes, right? And then if we just type out total eggs by itself and press return, that spits out the value that total eggs points to. So this was an assignment, this was an assignment, and we set a variable to equal the product of some computation. So you can do that in Python. OK, so we know about two data types. Remember, integers that don't know about the decimal place, and floats that do. Here's another super useful data type. We'll print some stuff out, and then we'll talk about it. OK, so check this out. Print hello, but in quotes. Can people see in the back? Is it too low? A little low? OK, we'll bring it up. There we go. Is that better?
Yeah.
Great. OK, so print, and then a space, and then hello in quotes. OK? I could print, and then a space, and then Jessica in quotes. These things in quotes are strings. Strings are just Python's way of saying bits of letters and other stuff together. It's like a word or a sentence, although it doesn't have to just have letters in it. So for example, So that's a string. And we know it's a string because it's in quotes. So strings are another type of data type, and they're just used to represent bits of data, like bits of text. You can, unlike in math class, in Python, variables are even more powerful because anything can be a variable. So we can have variables that point to strings as well. So for example, I could say name equals Jessica. And then I could use this print thing. We'll talk about print. Hello. Plus, let's see what that does. Name. OK. Name is an assignment. We have that single equal assignments assignment. Jessica is a string because it's in quotes. We know that we can add numbers. As it turns out, in Python, you can add strings as well. So we're going to add the string hello to the string pointed to by name. And then print is a keyword that says, like, print it out to my eyeballs, print it out to the screen. So think about what this is going to print out. So here's a question for you. What about this? How is that different? It's only different with a trailing space, right? So with strings, the spacing matters. With strings, Python's going to do exactly what you tell it to do. So if we wanted a space there, it's our job to add this space. That plus sign, people will call it string concatenation. Smooshing together strings with a plus sign is concatenation. All right, here's a little bit of trickiness for you. We know that we can add numbers to numbers. We know that we can add strings to strings. What happens if I do this? What happens if I try to add a string to a number? OK, interesting. Python didn't like that. But this is OK. This is nothing to be scared of. We're just going to read it, and we're going to figure out what it's telling us. OK, so Python is giving us a traceback, which means it encountered some kind of error. And it's saying, oh, it's a type error. I can't concatenate. I can't add or smoosh together strings and integers. I don't know how to add strings to integers. And OK, fair enough. I'm not sure what exactly Python would do there. So we can't add strings to integers. That's fine. But the main thing to know is what this thing is. So this thing called a traceback, you'll see it sometimes if you typo something in Python. And it's nothing to worry about. You just read it, figure out what went wrong, and correct yourself. So that's all that a traceback is. Here's a question for you. What is the difference between this and this? The second one is a string. Even though it looks like a number, it's in quotes that makes it a string. So keep that in mind. Another thing, single quotes versus double quotes. This is the same as this. Python doesn't care as long as you're consistent. So if you start with a double quote, end with a double quote. If you start with a single quote, end with a single quote. But other than that, Python doesn't care. Strings have lots of useful properties. For example, they have a length. And Python gives us a lot of, it gives us ways to figure out properties of strings. So here's one example. We'll type it and then we'll talk about it. OK, so I've typed some funny stuff here. And it spits out the number 5. What is this doing? Hello is a string. We know it's a string because it's in quotes. There's this thing called len. Len is a function. And functions in Python just mean useful bits of work that have been encapsulated and given a name. So len is a function, and its job is to give you the length of something. It takes one argument. It takes one thing that it's supposed to be operating on inside parentheses. And all functions work this way. Functions have a name, and then the stuff that they operate on inside parentheses. So in this case, len takes as one argument a string, and it spits out the length of the string. And that length is an integer. So we could stick some variable assignment into this too. So we could say fish equals tuna, and then take the len of fish. So len is our first function. That's pretty cool. Here's a funny thing about strings. We know that we can manipulate numbers. We know that we can multiply numbers. In Python, you can multiply strings. So think about what that might mean, and then let's try an experiment. Okay, so fish is a variable. It points to the string tuna. We're going to multiply that fish times 10. All right, now I don't know why you'd want to do that, but FYI, you can. Does anybody have any questions about integers, about floats, about math, about strings, or about printing?
Is there a list of like the functions somewhere?
Yeah, that's a great question. So like, how did I know that len existed and was a function? So we're going to talk about this and have some examples of this in a little bit. The honest truth is that programmers are super lazy, and they don't remember anything, and I just Google for stuff. So like, if I wanted to know like how to take the length of a string in Python, like I would type that into Google, and it would tell me. Now, there's some secret other stuff that you can do too. There's some official documentation online, and there's documentation built in that you can access using the interpreter. So if we wanted to check out this len function, I could use a help function. So we know it's a function because of the parentheses. So the name is function. Sorry, the name is help. It is a function. And it takes one argument, the thing that you want to get help on. So if we do this and press return, it will tell me a little bit about len and what it's supposed to do. And you can do this for anything. So the way to quit out of this, by the way, is to hit Q counterintuitively. So Q to quit out. But I could also say help on 1. And it tells me that it's an integer. And it tells me all about integers. I could also do help on a string. And it'll tell me all about strings. Well, fine, don't do it. OK, but in any case, that's not formatted super nicely, and I would honestly Google for it. But that's a good question. So Google is your friend when programming. Any other questions about strings, numbers, all that stuff?
Is there a way to list what assignments you've done?
Ooh, good question. Is there a way to list what assignments you've already done? I always forget this. So I'm about to Google for it unless somebody remembers. Anyone? Anyone? OK. OK, first thing, a couple of things to point out related to this question. Number one, when we said x equals 4, note that we didn't have to like pre-declare that x was going to care about integers. We just said x equals 4. And I can say x equals 4, and then I can go back and say x equals hello. You can reassign to whatever you want. Python doesn't care about that. And Python assumes that you are going to keep track of what's been going on. It doesn't enforce any rules about that stuff. OK, so the answer to the question of can I tell what assignments have been done is definitely yes. I don't remember what it is. So we can look it up. Oh, let's do in scope. OK. See, I wasn't kidding about the Googling thing. So this is a great object lesson. Even I don't remember anything and just Google for it. Dir. I like dir. Let's try dir. Dir. Dir is a function. We know because of the parentheses. All right, there you go. We don't know exactly, we haven't yet talked about all of the stuff here, but we recognize some of the things we've done already. We recognize magic number, we recognize x, we recognize total eggs, all of that stuff. So if you ever did want to know, you can use that dir function. There you go. Any other questions? Oh. Exactly. So there's some funny stuff going on under the hood. Python is defining some variables. They're predefining some stuff that we don't necessarily care about. But dir is going to tell you everything, even the stuff Python did for you. OK. Oh, another one? Ooh, another good question. What if I exited out of this, and then I started Python again? Would it remember this stuff? The answer is no. So this stuff exists for the lifetime of this interpreter session. And we'll talk about this a bit later. If you want to write useful stuff that you run over and over again, you would do this in a file that you run. You wouldn't do it at the interpreter. But we'll talk about that in a little bit. OK, so we got integers, we got floats, we got strings. I want to start being able to make choices. I want to start being able to compare things and make choices. So how do we compare things? OK, well let's do some experiments here. OK. 1 equals equals 1. Interesting. OK. 1 equals equals 1. Now remember, the single equals was an assignment. Double equals is a comparison. And when you do comparisons, it spits out a new data type called a Boolean. So this capital T true is its own new data type that represents truthiness, things being true. And 1 is in fact equal to 1, so it spits out a true. How about 1 equals 0? False, right? So capital F false is a Boolean that represents falsiness. You can compare a lot of things. You can compare strings. Is A equal to A? How about is little a equal to uppercase A? False. OK, so Python's case sensitive when you're doing comparisons. You can use not equal. Oh, yeah?
Talk about spaces. I see that you're putting spaces before and after the equal sign, but if I don't do them, then it's still.
Yeah, good question. So as before with math, Python in general does not care about spaces outside of strings. So we could also say A equals equals A. And that means the exact same thing. Python totally ignores the spaces. You can check if things are not equal. The way to do not equal is with this. So bang equal is not equal. So it's true that A is not equal to Z. Fair enough. You have all of those comparisons that you have in math class. So you can say, is 1 greater than 0? This is really asking a question. Is 1 greater than 0? And Python evaluates that and spits out a Boolean for the result, a Boolean true or false. You could say, is 2 greater than or equal to 3? Is -1 less than 0? Another cool thing, you can check for containment. Containment, what do I mean by that? You can check if H is in the string hello. Is H in the string hello? Okay. Is Z in the string hello? And this is part of how Python tends to be pretty human readable. A lot of times these keywords are just English words that you would use if you were vocalizing the comparison. So similarly, you can say not in. Is Z not in hello? And in fact, it is true that Z is not in hello. OK, and then just to make sure you're paying attention, what is the difference between this and this? What is the difference between x equals 4 and x equals 4? Assignment versus comparison. And I promise you'll forget that at least once. So keep it in mind. So equals equals is comparison. Does anybody have any questions about comparing things in Python?
Why do you write out not use the exclamation point?
Oh, that's a good question. So we said that we could say 1 does not equal 0. But then we also have this written out not in syntax. So the not equals is what you're going to use for math stuff. And the not in is what you're going to use for containment stuff. Any other questions? Yeah.
Is there an integer representation like in C? That's in like 0 equals false and 1 equals.
Ooh, okay, very, very tricky. Okay, so we have a tricky question here, which is, okay, so we know that we can make these comparisons, like 1 equals equals 1 evaluates to the Boolean true. What other things are true? Like, is the number 0, does that count as true or false? We're going to see some examples of that in a little bit.
Can you repeat the question?
Yeah, sure. Well, actually, to even not get sidebarred by it, don't even worry about it. We'll actually talk about it in a second. Although that brings up a good point. So what if I wanted the empty string? What does the empty string look like? Using what you know. Yeah, exactly. Empty quotes. What do you think the length of the empty string is? Exactly. Great. OK. We can compare things. But what we really want to do is be able to make choices based on these comparisons. So here's how you do this. I'm gonna show you some examples, and then we'll talk about what's actually going on here. Okay, making choices. Watch what I do, and then we'll break it down, because this is the first multi-line piece of Python we've talked about. Okay, if the string banana is in the string bananarama, colon, return, note that the prompt changed to dots. Python knows we're in the middle of something. Okay, we're in the middle of something. We're going to indent 4 spaces, 1, 2, 3, 4. And I'm going to print, I miss the 80s. Okay. If banana is in bananarama, colon, return, indent, print stuff. Okay, this is how you make choices in Python. You use this if keyword. You use if, and then after the if is something that evaluates to a Boolean. So some kind of comparison, some kind of check, some kind of question that gets answered. And we know that banana in bananarama would evaluate to the Boolean true, right? Okay, and then a colon at the end. And then indented under that if is stuff that you do only if that if expression is true. Only if that if expression is true. In this case, it is true that banana is in bananarama. So the stuff indented under the if will get executed. So if we press return to end the line, press return one more time to tell Python we're done, sure enough, it prints out I miss the 80s. If this had instead said, if banana not in bananarama, colon, print I miss the 80s, that expression would have been false. And the stuff indented under the if literally would never even have been looked at by Python. It won't get run. It won't print out anything. So this is how you make choices using if. Yeah? Yeah. So after the colon, you press return. And then you'll get, let's type this out again together just to make sure we're all on the same page. So if banana in bananarama, colon, return, we see the prompt change. We indent 4 spaces. Good question. Let me finish typing this and I'll... Okay, return to end the line. And then one more return to tell Python we're done. So the question was, does it have to be 4 spaces? It doesn't have to be 4 spaces. It needs to be a consistent number of spaces.
Right, you said it doesn't care about spaces.
Yeah, and that holds true here as well. So by convention, you indent by 4 spaces in Python. It's nice and clean and easy to read. If you're used to other programming languages, it might seem odd that Python cares so much about white space or forces you to indent stuff. There's actually a really good reason for this. So a bunch of people who study how people learn programming have done research on what makes programming languages readable. And as it turns out, the only thing that your brain cares about when you look at a program is how stuff is indented. So you can have as many curly braces and parentheses and all of that crap as you want. Your brain only cares about the white space. And the folks who designed Python just took that idea and ran with it. It's like, if your brain is optimized for caring about white space, we're going to make white space count so Python programs are readable. So you don't have a choice about indenting. You do have to be consistent about indenting, but there's no way around it. You have to indent.
So you can get 5 white spaces instead of a tab.
Oh, well, you can use tabs as well. I think space, yeah, you should be consistent. For the purposes of this tutorial, let's use spaces, because if you mix tabs and spaces, Python can get confused. Yeah.
But it could be 10 spaces.
Could be 10, could be 8, yeah. Yeah, and Python, the language, has guidelines for producing sort of consistently styled code, and the convention is 4. So might as well get in the habit. Okay, so this was our first multi-line bit of Python. Any questions about this? Making choices with if. We can do multiple things based on the outcome of some condition check. So let's type this out together and then we'll talk about it. So my sister is 15. My brother is 12. if my sister is older than my brother, colon, return, indent, okay? Indented under the if is some print statement. Return, but we're not done yet. Else, colon, return, indent, okay. We have that if from before. So first we do some variable assignments. We say my sister is 15 and my brother is 12. If my sister is older than my brother, colon, only in that case do I print out sister is older. This else colon says in all other cases, in all cases where this wasn't true, do this stuff. Do this stuff indented under the if, under the else. So let's run this and see what happens. Return to end the line. Return one more time to tell Python that we're done. And sure enough, because that first if was true, we do this stuff under the if. So now we get to do two things based on whether or not that if condition is true. Using that else keyword, we get to do one of two things. I didn't type any spaces here. Yeah, so these are, and the if and the else are flush to the left. All right, so let's do another example of this. So what if, okay, what it's like 70 out, maybe? Something like that, I'm making that up. Temperature equals 70, okay? Let's make some choices based on the temperature. So if the temperature is greater than 60 and the temperature is less than 75, colon, oops, this is wrapping a little bit, let me. Oh, come on. There we go. Okay, so if the temperature is less than 60 and the temperature is less than 75, colon, return, indent, it's a nice temperature for me. Return, else, return. Okay. So we've added a little wrinkle here. We can make multiple comparisons at a time. And if the net result is that the thing was true, then we do the work indented under the if. So in this case, we assign temperature to equal 70. And we say, okay, if the temperature is both greater than 60 and less than 75, colon, in that case, do the work indented under the if. In all other cases, else, colon, do the work indented under the else. So think about what that's going to print out. Okay? So making choices with if and else. We can make even more choices if we want. We can, in fact, make sort of an infinite number of choices using one final construction in this if-else syntax. So if you remember from this example before, about the sisters and the brothers, this is actually not totally accurate. In this case, if the sister is older, it prints out that the sister is older. But what happens if sister and brother were the same age? If they were the same age, what would get printed out? This part, right? So even if they're the same age, this part gets executed. And that's not really true. So why don't we add this last bit of syntax to make this expression more accurate? So let's just double check. Sister age is here. Let's set brother age to be 15 also. Okay, so now they're the same age. And we're going to say, okay, if sister age is greater than brother age, colon, return, indent, return. New construction. The new thing is elif. Elif, sister age, is the same as brother age, colon, return, indent. And then we're back to our else from before. Else colon. Okay, so that was a lot of typing, but let's break it down. Okay, we have these two variables, and we say, okay, if the sister is greater than the brother, print that the sister is older. Otherwise, a new condition to check. So if that first if wasn't true, let's try some other check. Otherwise, check if they're the same age. If they are, print out same age. And then in all other cases, if we haven't matched anything yet, if nothing yet has been true, then print this out. So this structure is always like this. At a bare minimum, you have an if. If you want a catch-all at the end, a catch-all at the end is the else. And then in between that if and that optional else, you can have as many of those elifs as you want to do more checks trying to find something that is true. And there's a little nice little reminder diagram here on page 4, just to keep you in line about the syntax, about what is optional and what isn't. Note here, the big thing to note here is that elif has some check it mix, right? Else is different. Else is the catch-all. You don't check anything in the else case. That's your catch-all, and you do it unconditionally at the end, if nothing else matched. So does this if, elif, else make sense? Using these three things, we can make as many choices as we want. So we can run this. We can press return to end the line, and return one more time to tell Python we're done. And sure enough, we don't match on the first if, but we do match on that elif. And that's what gets printed.
So the else would be completely disregarded.
Exactly. And you only ever do one thing. You only get one thing. So you could have if and then 10 different elif statements and then an else. You only get to do one. If the first if matches, if the first if evaluates to true, that's all you do, and then you just skip the rest of it. The same for if you go until you match the first thing that matches.
So if there's a syntax misspelling or something under else, it would never get evaluated?
Oh, very tricky, yeah. So if we had a typo here, but we never actually got to this part because we matched something earlier, yeah, Python wouldn't even notice. Python's very dynamic like that. It's not checking things ahead of time for you. It sort of trusts you to figure it out yourself. So this is a little bit tricky. Does anyone have any questions about this? About what the different parts are for?
How many layers can they have?
As many as you want. You can have as many infinite elif, well, not infinite, lots of elifs if you want. So the bare minimum you need is an if. I mean, if is your fundamental choice that you're making. Else is the catch-all. And then elifs are sort of for more fine-grained decision making.
Can you nest an if under an elif?
Ooh, okay, tricky question. Can you nest an if under an elif? Okay. So like what if we got into the sister age equals brother age case, can we like just go off and do another if condition? The answer is yes. You can nest this stuff as much as you want. So I could go off on some huge tangent indented under here if I wanted to. And in general, you can nest stuff in Python as much as you want. So you could have if you wanted. Yeah, good question. Yeah?
Tell Python not to do anything. So for instance, if sister age and brother age, do nothing.
Just do nothing? So the way to spell do nothing in Python is with the pass keyword. So if I wanted to say do nothing in the equality case, I could just have the letters PASS, pass, indented under it. And Python would just read that and say, okay, you meant to do nothing. So pass is the keyword. Other questions?
Does break work as well?
Hold that thought for, break is for when you're looping. And we'll talk about loops in a bit. Any other questions? Okay, fabulous. And then just one more thing I want to highlight is remember that you can do that. You can make multiple checks at once using that and keyword. There's also an or keyword. So and is so that both are true, or is so if either is true. And it reads like English, kind of nice.
Can these be replaced? Can and be or be replaced
No. Okay, great. So if there are no further questions, we're going to switch gears and we're going to get you practicing. So you solving problems in Python using these concepts. And this is, I want to emphasize how important this is to, great, perfect. So a lot of times intro classes, intro tutorials, following along with books, you don't get an opportunity to think about solving problems with programming. It's just following along. And that's tough, right? Because it's really like it's a thing you have to practice. It's a skill you have to develop. And you have to go through that mental work of doing the problem solving. So during this tutorial, we're going to give you a bunch of opportunities to do that and get those muscles stretched. So that's what we're going to switch gears and do next. All right, so here we go. OK, so all of this stuff is online. We're using a site called Code Academy. And we've written questions specifically for you folks. To do these exercises, just really quickly, you'll need to create an account on codeacademy.com. And then you visit this link. And you're going to go through the first section on strings and making choices. And what's going to be going on here is it's going to look very similar to the Python interpreter we've been using, just in a browser. Same deal. So if everyone can go ahead and visit this link. And for the next half hour-ish, we're going to go through questions. Get our fingers working practicing. So it'll look like this. Once you log in, it'll look like this. And it's thinking. And it's a similar deal to before. Imagine that this is you typing along at a Python interpreter. There's some code existing for you. And you're going to write some code here. And then once you've written your Python code, you press the Run button. And it'll do some checks on if you did the right thing. So everyone log in, and we can even maybe do the first one together if people have questions. Oh, I'm sorry. Yeah, let's go back to that. Yep, here we go. So number 1, create an account. Number 2, go start going through the practice. And we have a half hour to do this. And there's intentionally more material than you can hopefully finish. So do not worry about not finishing. There's bonus material for you to take home if you want. And raise your hand if you have any questions. Need help getting set up. Says, OK, our goal for this is to practice printing and manipulating numbers. And it gives us a little bit of setup. It says, so far, we have a variable called favorite number. Oh, I'm cheating a little bit, because I was already in the middle of doing this. So anyway, so yours will start out like this. So it starts out like this. It says, so far, we have a variable called favorite number. Our job is to use Python to print the result of calculating favorite number to the third power. So harkening back a little bit to math class, the third power, what does that mean? It means a times a times a, right? So do that calculation and print out the result. And our job is to add the print statement below the existing code on line 2. So in this case, pretty simple. Just do print, and then the calculation we want to do. So favorite number times favorite number, going off the screen a little bit. Times favorite number. And that's all there is to it. You just type that out, you press run, and it'll do some checks here. And if you got it wrong, it'll try to help you along. If you got it right, just go on to the next exercise. And there are 8 exercises in this section. OK? So again, for the next 25 minutes or so, this is what we're going to do. me again? Great. Okay, let's pick up with the second half of this tutorial. And just as a reminder on where we are, we had our break. We're going to go through some more really core stuff, like core programming concepts in Python, a little bit more practice, and then we're going to make sure you leave here with some concrete next steps for continuing to learn and practice the language. So for this next section, we're going to go back to a Python interpreter. So can everyone make sure that they can get back to the point where they see this? So start up your Python interpreter, and raise your hand if you've forgotten how to do that, and we'll help you. Alrighty. So far we've talked about a bunch of really good data types. We've talked about integers, we've talked about floats, we've talked about strings. We've talked about booleans, which come up when you make choices, when you make comparisons. So far, these have all been sort of individual things, like you have a string or you have an integer. What happens if you want to take care of a collection of objects, a collection of ideas? So for example, let's say that I had a grocery list, and I wanted to sort of express a grocery list in Python terms. Or I'm a scientist, and I'm running an experiment, and I have a bunch of results that I want to analyze. How can I store that in Python? So there's a data type for this in Python called a list. Lists are what you do when you want to store a bunch of data in order. So let's, again, interactively, so you type along with me, let's explore this list idea in Python. Okay, so first off, let's make a list. Okay. This is a list. It's called my list. We know it's a list because of the square brackets. A list contains comma-separated elements in square brackets. It means that this list has 3 elements. The first is a string. We know it's a string because of the quotes. The string A, and then the string B, and then the string C. Lists have a length, like strings. We know a function, len, that we can use to get the length of stuff. So we can find the length of this list. Len, and then inside parentheses, the thing you want to get the length of. And eyeballing it, that looks correct. We can get individual elements from the list using a kind of funny syntax. So I'll do it, and then we'll talk about what's going on. Let's say that I wanted to get that leftmost thing out of my list. This is what it would look like. So this is a little bit funny. Okay, so the syntax is the index of the thing you want to pull out inside square brackets. Python, like many programming languages, has made the choice to start counting at 0. So when you want to get the leftmost element in the list, it's actually the 0th element, and indexing starts at 0. So similarly, if we wanted to get the first element out of the list, we do that. And we can get the second. A kind of fun thing in Python is that you can get elements from the end of a list very easily. If you start at 0, how do you go from the end? With negative numbers. So what does this do? So the -1th element gives you the last thing in the list. So that's kind of fun, actually, because it means that without even knowing how long the list is, we can just use indices, including negative indices, to get various elements out. It's kind of fun.
-1 is always the last?
Exactly. And then by extension, given what we know about -1, what do you think -2 does?
Right after that.
Exactly, so moving from right to left. Exactly. And it has a reminder, this is what my list looks like. Cool. What happens if we try to get something outside the range of my list? So we have 0, 1, 2. What if I try to get the 3rd index? All right. Python didn't like that. But we've seen this before. We've seen a traceback before. No need to worry. We just read it and figure out what's going on. It says in this case we have an index error. The list index is out of range. Fair enough. Because we don't have a 3rd element. But let's add a 3rd element. Let's append a new item to the end of this list. We have a funny syntax for this. I'm going to type it and then we'll talk about it. This is the way that you add things to the end of lists. And this is a new kind of syntax. So let's see what the list looks like now, and then we'll talk about why that syntax looks the way it does. So sure enough, my list used to have just ABC. I used this funny append thing here, and then it's grown a new element. So let's break down this syntax. Append is a function. We know it's a function because it does stuff in parentheses. In this case, the thing you want to add on to the end of the list is in parentheses. MyList dot function means this is a function that lists know about. So lists have lots of functions associated with them. You can do lots of things with lists. And the way that you use these list functions is with the variable list, dot, and then the function name, and then the parentheses. So that's what that syntax means. So we can append things. So we can append another thing if we wanted to. Great. And now if we take the length of the list, what should it be? Right. And now we could index in to the 0, 1st, 2nd, 3rd element. And it won't give us an error anymore, because now we have stuff there. We can change things in lists. Maybe I was never so hot on the letter A. So what if I want to get rid of it? I want to replace it with a Z. So my list currently looks like this, and we say A, you're out. Z is in. How do we do that? I hear someone guessing. OK, so if we want to replace an element in the list, first pull it out. First pull out the index that you care about, and then do an assignment. So use a square bracket notation and then an assignment. So if we do this, and then look at my list, boom, there we go. A is out, Z is in. So not only can you add things to lists, you can change things in lists. Lists are mutable.
Might cover this, but how can you tell what, can you do a search to see what its index is? Like if I want to see what index C was?
Yeah, good question. So like what if I wanted to know where in a list an element was? Like where in my list is C? Let's see if I'm butchering the syntax here. OK, so I think this is right. Nope. OK, what is it? Index. Help. Giles, do you know? I want to get the index of an element.
Dot index?
Good guess. Very good. OK, I was not kidding when I said I don't retain information. I would just Google this stuff. So again, lesson for you. OK, so but this is cool because it's the same syntax from the append thing, right? So lists, you can do lots of things on lists. List dot function name, arguments to function. OK, so good question. Where was I? You can check for containment using that same in keyword we used for strings. So if you remember from earlier, we could say h in hello, and that spits out a Boolean. We can do the exact same thing for lists. I could do A in my list, or Z in my list. That's cool. You can slice and dice lists, which is kind of fun. So we know that we can extract a single element like this. We can also extract or slice a range of elements using this sort of funny colon extended syntax. So this says, instead of just taking the first, taking the 0th, sorry. Instead of taking just the 0th element, take the 0th up to but not including the second. 0th up to but not including the second. So by extension, what does this do? Yeah? Another cool thing is you can leave off the bounds. So I could leave off the left side of the colon, and that it's implicit that you mean start at the beginning. Or I could leave off the right side of a colon, and it's implicit that I mean all the way to the end. So for example, I could say, and that gives me everything up to but not including the third. Or I could say, start at the second, and go to the end. Okay, by extension, what do you think this does? It makes a copy of the whole list. Start at the beginning and go to the end. It's kind of fun. This is super powerful. And I know that some folks here have not programmed before. That's great, we love you. If you have programmed before, you may be used to having to care about the length of things a lot, right? And having to find the index and look things up by the index. In Python, it's super easy. You never have to care about the length. It's all implicit. You just operate on strings on lists without having to know how long stuff is or looking at the index first. Very, very powerful. Strings are a lot like lists, as you've probably noticed. So we already know that we can take the length of a string as well as the length of a list, stuff like that. So we can similarly use this slicing syntax on strings. So if I have my string equals hello world, I can do this. Same slicing syntax from before. Or, it's kind of fun. You can have lots of stuff in lists. It doesn't have to just be letters. So I could say that your list equals just all kinds of things. Hello, 1, true, -0.5. You can mix and match all of these things if you want. Python doesn't care. It's your job as the programmer to do useful work with that list afterwards. So okay, let's get some names in a list. Okay, so we have a list. We can get the length with that len function. We can get the 0th element using this slicing syntax. We can check for containment within. And we could use this inside an if condition, right? So we can make some choices based on these comparisons, based on this containment. You can do lots of stuff on lists. You can use, we already have found the length. We've already been slicing. A couple of other useful ones. What if I did this? So here's what names looks like. This is a function that lists know about that sorts it. So I run that. There you go. Let's say that I had a bunch of numbers. I can find the maximum value of the list. I can find the minimum value. In general, if there's a thing you think you can do to a list of stuff, you probably can. Just Google for the way to do it. Does anybody have any questions about lists, or what you can do with them, or why you would use them? How can we figure out the list that we've created? Oh, well, we can use that thing from before. Does anybody remember? So it's the D. Ders. Dir. So we can use that dir function from before to tell us everything that we've defined, not just lists. We can see my list. We can see names. We can see numbers. That's another question? Yeah.
So some of these, you're doing like min and like parentheses and you're putting something at the start,
Yeah, that's a very good question. So we've seen sort of two types of syntax, right? So we've seen this len thing. So a thing that you can do to a list is get the length, and length is a function. But we've also seen a syntax like this, right? And what is the difference? The answer is a little bit tricky, and it's hard. You can't just know a priori what the right way to do this is. This is more like sorting is a thing that lists know how to do, and len is a function that can operate on potentially lots of different data types, like not only just lists but also strings. And so it's this. I'm being a little bit hand wavy here, but this is more like len can possibly apply to many things. Sorting is a thing you do on lists. You can't sort a string. Good question, though. Other questions about lists or why you would use them?
Where would you get like
yeah, like where do you come across lists in the real world? So there are a lot of ways to use them. We'll see some of this in a little bit. But in short, in Python, you can loop through files. You can read lines out of files. You can do math, and then as you do math, we're going to talk about loops in just a little bit, but you can do a loop that builds up a list, things like that. Good question. Anything else? Yeah.
When I'm sorting the numbers that you displayed there, for point 6, it's displaying like 0.5999 instead of 0.6.
Oh, that's funny. Okay, so so the comment was I had the number, like I typed 0.6, but the way it's being displayed in the list is 0.5999999. So awfully close to 6, but not 0.6, but close. So Python under the hood for this float, this thing that knows about a decimal point, it has to figure out an efficient way of representing it. And there are a lot of rules about how to do that, and sometimes it doesn't quite show you the right thing sometimes. It is, for all intents and purposes, 0.6. So this is not you doing anything. It's Python being weird under the hood.
Is that per version of Python, or?
It's going to be dependent upon a lot of things. It's going to be dependent upon your operating system in particular. Yeah. Other questions? Okay, so lists are cool, but the real power of lists comes with when you can loop over lists. So we're going to talk about looping over lists next. Okay, so I'm going to do an example, and we're going to talk about it. So type it along with me, but then we'll explain what's going on. So we have this names list. Okay, for name in names colon. Return, indent, 4 spaces, print the name. For name in names colon, print the name. Press return to end the line. Return one more time to say that we're done. Interesting. So what do we do here? This is a for loop, hence the for keyword. For loops are when you loop over every element in a list and do something for each element in the list. The syntax is for variable name in list name, colon. So we get to choose that thing right after the for. That's a variable name that we choose. And after we've chosen that variable name, we get to use it to do a useful bit of work on each element in the list in turn. So I could have equivalently done this. For x in names, print x. Exactly the same. I choose the variable name x, and then I get to use it indented in the for loop to operate on every element in turn. Let's make this a little bit fancier. What do we say? For name in names, colon, return, indent, print, hello, name. Think about what this is going to do. Print hello and then the name. So this is very cool. So pretend that I'm a scientist, and I have done a giant experiment, and I have accumulated 10 billion DNA base pairs, because I am a DNA scientist, and that's what I do, right? Okay, I have 10 billion base pairs, and I need to do something for every result in that list. Using a for loop, I do the same, it's the same amount of work for one element, gets applied to all of them. I only had to type the work for one element, and the for loop applies it to all of the elements. So I didn't have to type something out 10 billion times. I only had to type it out once, and Python did all the work for me. I mean, this is like the essence of computers being powerful, right? So like if I wanted to loop through every word in the dictionary, that could take me my whole lifetime. In Python, using a computer, it's instantaneous, approximately. So this is a very, very cool, powerful thing. And again, it was easy. Like I didn't have to know what was in the list. I didn't have to know how long the list was. Like I didn't have to care about any of that stuff. Just for name in names, colon, do useful work. It's very powerful. Does anybody have any questions about the syntax? Yes?
Somehow, for me, instead of coming up with each name, it's taking the name Zelda. So I'm getting hello Z.
Ooh, yeah. Oh, that's very cool. Okay, so we're going to run a little experiment here. We're going to run an experiment. Okay. Remember I said earlier that strings are a lot like lists. You can take the length, you can slice them and dice them, all that stuff. Check this out. Let's say that I have name equals Zelda. Name is a string. What if I say, for x in name, colon, return, indent, print x. Okay, for every element, for every little bit of name, print that little bit. What do you think the sort of individual element of a string is? It's a single character, right? So that when you loop over a string, which you can do with a for loop, as we'll see, what you're doing is you're doing it character at a time. So if we run this, that's why that's happening. Because you were looping over a string and not a list. Does that make sense? Maybe. Think about that. Well, we'll get back to this again. Yeah. So the thing, whatever the thing is at the end, it's going to loop over it. So if name is a list, you're going to loop over a list. If name is a string, you're going to loop over a string. Yeah. Was there another question? Yeah.
Yeah. So you have 4 names and names. Could name be anything?
Name can be any variable you choose. For Fido in names, for X in names, for, whatever.
You might want to remind people how to check what they assigned their single variable to. Like if they don't remember what they assigned to name, or if they assigned.
Oh, okay. If you wanted to double check what name was, you can just type it by itself and press return, and Python will remind you. It'll spit out to the screen what it was equal to. But so we pick the variable. So we could say for x in name, for x in names, for name in names, and then we use that variable name indented inside the for loop to do useful bits of work. Let's see another example of this that will, I think, help solidify it. Okay, we're going to get a little bit fancy here. Okay, this is a reminder on what names looks like. Okay, let's try this out. For name in names, colon. We're going to type it along with me, and then we'll break it down. If name 0 is in AEIOU, colon, return, I'm going to indent inside the for loop. And then I'm going to indent one more time for the if condition. Okay. So now this is a tricky one. We're going to break it down together. Okay, for every name in this list of names, where this is a variable name that I've chosen, for every name in this list of names, if the leftmost letter in the name, the leftmost letter in the name is a vowel. So like if the leftmost letter were an A, is A in this string, A-E-I-O-U. If the leftmost letter is a vowel, then print that name starts with a vowel. So we have a for loop. We're going to loop for every element in the list. For every element in the list, we're going to check the first character. If it's a vowel, we're going to print something out. What are we going to do if it doesn't start with a vowel? We do nothing, right? We do nothing. All right, so let's see what this does. Is the indenting cool? We have an indent for the for loop, but then another indent for the if.
So how do I clear what name is if I want to use that?
Oh, I see. Hold that thought for just 1 second. We'll run it and then we'll talk about that. So, okay, I'm going to hit return to say that we're done with the line. Return one more time to say that we're done with the for loop. Think about what this is going to print out. There you go.
So the 0, it's the leftmost or the first character or whatever in that item.
Exactly. So like if I say, your name equals Billy, your name 0 is going to pull out the leftmost thing. And we're doing that exact idea, but for every name in the list of names through this for loop. And then we make a choice based on, so your name is 0, we can make, and then we do that check. Is it in the list of vowel, or is it a vowel? Is B a vowel? And it's not, right? And then based on that choice, we maybe print something.
So just basic for them, it's for name, you're taking an individual object in that list, and then you're selecting that 0 position on that.
Exactly. Exactly. So this is a trickier example, right? And it's exercising a couple of things we've just talked about. It's indexing into strings or lists, indexing into strings, using that in-word for containment. Not only do we have a for loop, but we're also making choices inside the for loop with that if. So let's digest this and make sure we understand it. Now we had a question about what if I wanted, like what if I'd already used the name variable before and I wanted to unset it? There's not really a notion of unsetting in Python. But the secret thing here is, even though I've assigned name to Zelda, when I reuse the variable name in the for loop, that's its own little separate thing. So like it's going to overwrite name. So even if it was name already equals Zelda, when I go through that for loop and I use name as the variable name, it's going to get reassigned to every new variable in turn. So let's just, if we walk through this, right? So names is this list. If I have this for loop, when I go through the for loop, I literally do, okay, first name equals Bob. Then do some work based on Bob. Then go through the for loop again. Name is assigned to Ellen. Do some work based on Ellen. Go through the for loop again. Name is assigned to Rick. So the assignment is happening in the for loop to be the right thing. So you don't have to worry about the fact that name was already used ahead of time. Because in the for loop, the assignment is happening.
But say you just wanted to clear it out.
I mean, you can, there's no notion of, there's not really a notion of unassigning. You can't say, okay.
If you do like your
I don't want to get into that.
quote, like two double quotes.
So, okay, so we could do a couple of things here, right? So let's say that we didn't want name to equal Zelda. I could say that name equals the empty string. That's totally fine. We could do that. And it would be empty. So if that's what you want to achieve, you can do that. You can always overwrite assignments. You can always assign a variable to something new. Is that a good enough answer?
Yes.
Okay. Okay, so how do you feel about this for loop? Any questions? I see a maybe question.
So I put in an else statement.
Yeah.
You would only evaluate anything after the true statement that comes back with valid.
Right, so like what if we wanted to change this example? Let's just do it together. Like what if we wanted to extend this example to print out if it starts with a consonant? Exactly. So so we want to, based on whether or not the first letter starts with a vowel, if it does, print that thing. Else, print that it starts with a consonant. So let's think about how to do that, and let's do it together. Okay, so we're going to do a for loop. So step 0 is write our for loop. For name in names, colon, indent. Okay, if the leftmost letter is a vowel, okay, if the leftmost letter is a vowel, colon, return. Indent under the for loop, indent again for the if, print, name starts with a vowel. Okay, we hit return to end the line. Python knows we're still working on something. We're still inside the for loop, so we still indent 4 spaces. And then flush with the if, we have our catch-all case. We have our else. Else colon. Right? Return, still indented. We need to be indented under the else. So 4 for the for loop, 4 for the else. Okay, beautiful example. If this thing is true, do the work indented under it. In all other cases, do this. You buy that? Yeah.
You always want else by itself on its own line.
Yeah, so else doesn't take a condition. It's a catch-all. If we wanted to be checking something else, we would use that elif. So if, elif, else, right? All right, so let's run this and see what happens. Return it in the line. Return one more time so we're done. There you go. So making choices using if inside a for loop. Okay, let's tweak this example. Oh, yes? How to make it not case sensitive? There are a couple of ways to do that. Okay, I'll talk about 2 ways to do it. One is that we could make the string be A-E-I-O-U, A-E-I-O-U, and check if it's in the list of both upper and lowercase strings. Another thing you can do to strings, we won't totally get into this, but if this is my name, there's another function you can use on strings that will lowercase it. There's also a function to uppercase it. As I mentioned before, if you think you can do something to a string, you probably can in Python. Yeah.
So you could do name bracket 0, close bracket dot lower?
You can lowercase, well, so name 0 is, that's just a single letter, right?
Yeah, but say if we chose 2.
Oh, I see, yes. You can lowercase a string or a single character, which is still a string. Yeah, exactly. Good question. Other questions? This is tricky stuff. My understanding is that for loops are like the hardest concept. Like this is a general programming concept. All programming languages have for loops. They're going to look a little different depending on the programming language, but this is like a conceptual thing. This idea of looping over a list, it's super important. It's why computers are powerful, so we definitely want to understand it before we leave the room. Okay, so let's switch up this example. What if I wanted to build up a list of names that start with vowels? We had asked about building up lists earlier. So how do you build up a list? Well, question number 1 is, what does an empty list look like? Given what we know about the list syntax, what does an empty list look like? Yeah. So let's say vowel names equals just open close bracket. Empty list. We know it's empty. We can use the len function to confirm that it's empty. Okay, what I want to do now is I want to loop through our list of names, and I want to build up, by using that append function, I want to build up a list containing only the names that start with vowels. So let's type that out together, see if we can figure that out. For name in names, colon, 1, 2, 3, 4, if name 0 in A-E-I-O-U, colon. We're not going to print anything. This time we're going to append to our new vowel list. Okay. For every name in the list of names, if that name starts with a vowel, append it, add it to the end of our currently empty vowel names list. Okay, end the line, end the for loop. Now what should vowel names contain? Exactly. So important idea. You can build up lists using the append function inside for loops. You might start it with an empty list and you use that append function. At the end, it contains what you want. After having gone through the for loop the whole time, all of the times, at the end out pops vowel names with the contents we'd expect. So building up a list, important idea. Here's another important idea. Let's say that we wanted to write our own len calculation. Like we know that len, the function, exists, but what if we wanted to do that ourselves? So we have our list of names, and my goal was to, in a for loop, count up how many elements were in this list. How do we do that? Well, step number 1 is we need a counter. So let's add a counter. Let's add a variable called counter and set it equal to 0. And now what we're going to do is we're going to loop through the list, and every time we see an element, we're going to increment the counter. We're going to add 1 to the counter. So for name in names, colon, counter equals, okay, this is a little tricky, counter plus 1. Increment counter, add 1 to counter, and then assign it back to counter. Counter equals counter plus 1. So we end the for loop, we end the line, end the for loop. Now what does counter equal? That's interesting. So this idea of keeping track of something, of counting something, of building something up inside a for loop is very common. And the trick to that is you may need to set up a variable before the for loop that you manipulate inside the for loop for each element. Does that concept make sense? Any questions? If I had started counter at 1, yeah, exactly. And then I would have added 1 to each time, it would have ended at 5. How about this? What if I wanted to build up a string? What if I had a bunch of words in a list and I wanted to construct a sentence out of that list of words? So I'm going to build something up. That means I need something to store the string that I'm building up. So I'm going to start with an empty string. Empty string, we know, looks like quote, quote, right? So our goal here is to build up a sentence out of the words in the list. So, okay, for name in names, colon, return. Similar to before, sentence equals sentence plus name. First, concatenate, add together, add to the end of sentence, name, and then assign it back to sentence. That's going to build it up as we go through the for loop. So think about white space, think about spaces, think about what this is going to do at the end. Okay, so it did exactly what we told it to do. All it did was it smooshed name after name after name. What if we wanted to add spaces between those names? Exactly, so we could have said sentence equals sentence plus space plus name, just like with that Code Academy exercise from earlier. So the key idea here is all the same, though. You start out with a variable that you build up, or you increment, or you keep track of things with before the for loop, and then you manipulate it inside the for loop, and then you check it afterwards. And as you might expect, and as we saw before, so you can make choices inside for loops. You can make as many nested if choices as you want inside a for loop. You can even have for loops inside for loops. So you can have the inception of for loops all you want in Python. You just have to keep the indenting correct, right? So just be careful about the indenting, but you can do that as much as you want. And if you forget the syntax, your cheat sheets will help you remember this stuff. Okay, so loops. You loop over lists. Lists are what you use for storing a collection in an order. And this is a syntax for looping over stuff. Any questions?
I tried to add an extra space after sentence.
Mm-hmm.
So sentence space plus name. And I got like Bob, Ellen, Rick, Zelda. I got a weird result.
Maybe we'll have someone come check and see what's up with that. Is that okay?
Well, I just
Put that result with the spaced out result, so you got both, right?
Oh, I see. Oh, is it that you didn't clear a sentence? Is that right? Oh, yeah. Okay, good call. Good call. Yeah. Cool. So this is one of those like practice makes perfect things. So any questions before I set you loose on some Code Academy practice questions? Saving the list? What do you mean by saving it? Yeah, so, okay, good question. So we've been doing all of this work. Like, it's just going to go away when I restart the interpreter. What do I do about that? So we're going to talk about this a little bit in sort of the final section of this tutorial. But one thing to know is that this interactive interpreter is mostly for doodling around. If you're doing any substantial work, you have like a real project that you're working on, you do that in files. And you can execute the content of files with Python. So that way you can make typos, you can clean them up, you can tweak them, all of that stuff, and then you run the files themselves. So we're mostly using this just because it's efficient for teaching, but you would actually do this in a file. And the other thing is that you can use Python to read from and write to files. So if you wanted to, you could store that list written to disk in a file. So all of that stuff is possible.
In a text file.
In a text file, exactly. Good question. Anything else? All right, okay, so the next section for us is, again, practice, practice, practice on the syntax. So what we're going to do is please visit that same URL from before, same Codecademy setup, section 2, lists and loops. And we're going to give you a nice long while to get through a bunch of these, get practicing the syntax and the indenting and the mechanics. And again, if you get stuck, raise your hand, we're here to help. Say hi to a neighbor, collaborate, that stuff's all encouraged, okay? But for the next at least half hour, we're going to work through these, okay? So everyone pull up Codecademy and get started. So now that you've been going through, whoa, okay. Now that we've been going through a bunch of for loops and lists and all that good stuff, does anyone have any questions? Stuff that's come up in the examples that you want to talk about? Things you're not sure you can do with lists, other good stuff. Any questions? Examples you want to see again? Yes?
The remove files. This one, for example, is kind of stuck on it. Removing the vowels and storing them into it.
Sure, yeah. Okay, so, oh, how did I do? Okay, so one thing that someone wants to go over is an example where we're building up a string that has all of the vowels removed. So why don't we just go through that together as an example? So I'm going to go back to the interpreter. If I can find it. Here we go. Okay, so, and I have some sentence. I don't know what it is. It's something like that. It's some sentence, okay? And our goal is to use a for loop to construct that sentence, but with all of the vowels removed. So this sounds similar to a thing that we talked about earlier. We're going to be building up a string from scratch. So before we do any sort of for loop, let's create a variable that's going to hold the resulting string with no vowels. So sentence without vowels is just an empty string. Okay, we're going to loop through this sentence letter by letter. What does that for loop look like? So for, we pick the variable name. In this case, a meaningful one is letter. For letter in sentence, colon, return. Okay, so if the letter, if it's not a vowel, right? If it's not a vowel, we're going to add it to the end of this sentence without vowels variable. So how about this? Here's my proposal to you. There are a couple of ways to do this, but here's one way. If letter is not in A-E-I-O-U, A-E-I-O-U, for every letter in that sentence, if that letter is not a vowel, colon, indent under the for loop, indent under the if. What do we want to do in this case? In the case where it's not a vowel, we want to append it, or rather, we want to add it to the end of that string. And we construct strings, we smoosh strings together with a plus sign, right, with concatenation. So sentence without vowels equals sentence without vowels plus letter. Vowels, thank you. Plus letter. I know it's wrapping around, but pretend it's not. Okay, plus letter. So we have our current sentence, and we're going to tack a letter onto the end of it. I end the line. I tell Python that I'm done. It churned through, letter by letter, appending to that string when appropriate. And now we can check what sentence without vowels contains. There you go. Does that example make sense? We got for loops, we're making choices, we're using that not in, that containment stuff. We're appending to a string, we're adding to the end of a string. Any other questions about for loops or lists or the stuff that we've been covering? Yes?
Can you do the last one with words and vowels?
In the interest of time, because it's a little bit tricky, maybe we'll talk about that afterwards. Is that okay?
Is it 2 for loops?
Yes. Yes. Cool. Okay, so we're going to switch gears a little bit. As we talked about earlier, we've been working at this interactive interpreter because it's convenient for quickly trying things out. But really, you do real work in files. So you can save your work and edit it and run it at your leisure. So I have some examples of some Python files, we call them scripts, that do little bits of useful work. And the intention with these is not necessarily for us to understand every piece of it, but is to start getting a sense of what is possible with just a few lines of Python. These examples will all be online later, so don't worry about getting them now, but I have them locally and they'll be available to you later. So let's see here. Okay, so I have a bunch of files. They end in .py, which tells everybody that they're Python files. The way that I can run them is with that same old Python command from before, but with the file name afterwards. So first I'm going to run this timezone.py file, and then we'll look at it and see what it looks like. So Python and then a space and then the file name. Okay. So this file, inside this file is some Python code that has some print statements that spits out some useful stuff. So here's the output. Let's have a look at the file. Okay. So this is the whole file. We're interested in this in broad strokes right now. So a couple of things to know. Number one, there are these pound signs. Pound signs are comments in Python. That's for you to take notes to explain what your code is doing. Python does not try to run those lines. They're just for you to explain what's going on. We see some print statements. We know all about print statements. Great. We see another interesting thing here at the top, this import line. So a lot of stuff is built right into Python. It's just available to you. Like that len function from before, like these list things and all the various functions that we've seen, those are just available to you in Python. There's even more stuff that has been written that is useful in Python that is not available to you unless you say you would like to use it. And to say that you would like to use that stuff, you use this import keyword, and then the name of this thing, this file, we call it a module, that contains a bunch of useful stuff, typically grouped by what it's for. So in this case, there's a module in Python called datetime that's all about manipulating dates and times. And if we do that import datetime line, we then have access to all of the functions and all of the useful stuff in that module. And if you see, on a bunch of these lines, we do datetime.stuff. Datetime.stuff. So just like when we had a list, and it was like list.sorts, or list.append, same deal here. The dot means this is a function from datetime, from the datetime module. And then it's a function, and then it takes arguments parentheses. So the meta thing to know about this example is that there are lots of useful modules. You import them, and then you get to use them in your file. One of them is the datetime module. And just to show you again what that output looked like, here's another example. This one is a tip calculator. Oh, sorry, yeah.
The other example, there is not just something in the brackets, but there is hours, it's not 11, but hours equal 11.
Oh, yeah. So we haven't talked about this yet, and don't worry about it, because you'll learn about it if you go through a longer form tutorial. But sometimes arguments are optional, sometimes arguments are optional, and you have to say which argument you're talking about. So this is saying, I want the hours argument to this function to be equal to 8. But don't get caught up on the details. OK, so this is a pretty short script, but get some useful work done. That's pretty cool, using the datetime module. Here's another example. Really short, like 14 lines of code with comments. It imports another really useful module called the sys module. And the sys module has a bunch of useful stuff, but one of the things it lets you do is access command line arguments to scripts. So if people can run your Python scripts, your Python files, with some other stuff on the command line, and you can capture that and use that information in your program. So that's kind of cool. So in this case, this script is expecting you to pass in an amount, like how much money you spent at dinner. And it will calculate various tip values based on the amount that you provide to this script. So let's run it, and then we'll look at this again. So let's say that I spent $56.78 at dinner. It calculates, if you want to be a really generous tipper or a less generous tipper, it makes that easy for you, right? And this is dependent on what I pass in. So I could have said, $5.60, and it will do the math based on what you provide. So that's very cool. And sort of the meta thing to take away from this example is that you can interact with the user who runs your program. They can pass in data on the command line, and Python makes it very easy, just a couple of lines of code, to pull in what they provide and do computation based on what they provided using the sys module. So it's very cool. And again, we know a lot of this stuff already. We know all about for loops. We are experts at for loops. We know all about print statements. So there's not a lot more. There's like a 10% of magic here, but you know 90% of this. Here's another example for you. I will run it, and then we'll look at it. Some of you have already seen this example. Okay, this one is a state capitals quizzer. Anyone have kids here? Kids, they want help with their homework. Okay, the next time your kid says, I want help with my homework, you say, no, I won't help you with your homework, but I've written a Python script that will help you with your homework. So this is the game plan going forward for you all, okay? Python scripts to help your kids with their homework. Okay, state capitals.py. Let's just run it and see what happens. Okay, you're gonna have to help me here. What is the capital of West Virginia?
Charleston.
Is it? Charleston. That sounds good. Great. Alaska. I know that one. Juneau. Well, that's randomness for you. Okay, Juneau. Louisiana. Baton Rouge. New Mexico. Anyone? Santa Fe? Santa. This is embarrassing. The kids will know better than us, really. Okay, great. Okay, so this is a fun little example. This is like user interaction one level above the tip calculator from before. In this example, in the program, inside the program, you are requesting user input and doing some work based on that user input. So in this case, we're running this script. It's asking, we're asking for a specific value, like the capital of West Virginia. And we capture the input from the user and check if it's right. So let's see what that looks like.
Quick question.
Yeah.
How would you avoid the duplicate question? Is there something for that?
So let's talk about what's actually going on, and then we'll talk about that. Okay, so this has a little bit of magic like before. The vast majority of this file is just another data type that we haven't covered yet, called a dictionary. And dictionaries are all about looking at values based on their keys. So like a real dictionary, or like an address book. So dictionaries in Python make it easy to, given a key, given a state, look up the value, look up a capital. So that's just a bunch of data. That's just all the capitals. And then the meat of it is just this couple of lines at the bottom. We see another useful module, the random module. We import it here so we can use functions related to randomness. In this particular case, we use the random module to randomly pick a state from a list of states. We have a for loop and a list. We know about those. And then the magic here, the magic that lets you talk, interact, have your program interact with the user, is this raw input function. So raw input lets you say, it has the program pause and wait for the person using your program to type some stuff in and press return. And then it captures, it does an assignment to what they typed so that you can then do computation based on what they typed in. It does a comparison. It checks if the guess typed in by the user is equal to the actual capital and prints a reasonable statement based on if they were right or wrong. So a question that we had was, well, how could we avoid duplicating the same capital over and over? We could keep track. So we could keep track maybe in a list of all of the states that we've asked about. And if we randomly choose one that we've already asked about, just get another random choice. Right. But a list would be a great data structure for keeping track of that stuff. Good question.
Basically, make a list, like after you generate the question, you generate a list of each.
Yeah, so I might have an empty list at the beginning.
Yeah.
And as I go through the quizzing, after I've picked a state, append it to that list. And like that list is, that variable name might be states already used. And just append to it each time. And then check for containment with that in keyword. You know, if Hawaii is in states already used, then just skip it. Cool. So I think this is a fun example. And you know, we don't know exactly all of this stuff, but this is like 10 lines of code. This is like legitimately useful software at this point, right? With not very much work. This is one of the powers of Python. Any questions about this?
What about module? How do I know what module is available and what module to use?
Well, can you guess what my answer to this is? You Google for it. You're like, hey, can I do random things in Python? And you Google for it, and it's like, yes, the random module. And this is true for like basically everything. So if you're like, I would like to interact with Twitter using Python, you Google for Python Twitter module, and you will find that sure enough, people have written that stuff for you. So literally everything.
You have to download it, or?
Yeah, so in some cases, so like random is a module that came installed with Python. For other super extra stuff, like the Twitter stuff, you would download it, install it, and then Python will know where to look for it.
Or it could be a package, like a Python module that you could like yum install some module.
Exactly, so yeah, exactly. And at the end of the day, all that does is it says, hey, put that Python code in that module in a place where Python knows to look for it.
Can I add just-
Yeah, go for it.
I just wanted to say that Python comes with an amazing amount of stuff, like right from the get-go. It's probably in there. And if it's not, then just Google it, right? Probably somebody's written it. And that's the awesome thing about it. The other thing is that Python documentation that comes with Python is excellent.
Very true. Okay, one other fun example. Okay, so I don't know about you. Does anybody play Scrabble? Words with Friends? Yes, I hear a resounding yes for Words with. Okay, so I was visiting home for last Christmas, and my dad and I like to play Scrabble. I got him hooked on Words with Friends though, and we were playing a Words with Friends game. And like, you know, I was off doing my own thing, and he was in his little man cave. And I walk in, and I see that this guy, my father, has like a list, you know, he has pulled up a page that has a list of all of the two-letter Scrabble words. Because he was cheating. Like, my dad was cheating at Words with Friends with me, his daughter. Okay, and my reaction to this, of course, is, okay, if you're going to cheat at Scrabble, I am going to cheat at Scrabble better than you, right? Okay, so here is a little script that helps you cheat at Scrabble. It again takes user input. So you would give it your Scrabble rack. So let's say that I have, you know, whatever, A, E, blah, 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 whatever. It takes some Scrabble rack. And it thinks a little bit, and then it spits out, using the Scrabble you know, letter values, the best words you can make with your rack. So take that, Dad. You know, good luck. And this is, again, we don't know exactly everything that happens here, but it's not that much code. It's like 30 lines of code. It's not that bad. We have some for loops, we have some if statements, we have some Booleans. We know a lot of this. So there you go. And like I said, I'll do the outro slides in a bit. This stuff is all online. So if you would like to cheat with your friends and family at Words with Friends, you'll have access to this script as well. Okay, any questions about these examples, about what is possible with Python? Great, well, we are almost out of time, so I'm going to hurry-scurry through my brief outro slides. Okay, here we go. Okay, you did it. Great, okay. Okay, so congratulations. You've gone through an intro to Python tutorial. This is what I hope is the beginning of a long and fruitful and productive career with programming. And a good thing to remember is that programming basics, like these for loops, this idea of variables, this idea of lists, this is shared across languages. So you will get to reuse these concepts for the rest of your life. So it's good stuff to know. What is the realistic next step for you all leaving the door today? So there's only so much we can cover in 3 hours. The realistic first step for most of you is to go through a full-fledged Python tutorial. That's going to cover more of the data types, more of the important modules, all of that good stuff. Here is my preferred text for folks who don't have prior programming experience. It's called Think Python. It is available for free online as a PDF. You can also buy it through O'Reilly. It was written by a guy who's a friend of mine, Alan Downey. He's a professor at Olin. So he, as his career, teaches kids how to program. Teaches, well, kids, college students how to program. So I really like this text. It's very good at introducing the sort of the conceptual underpinnings along with practical programming. So this is my preferred text for you. And so my recommendation as you leave this door, pick up the PDF and get a game plan for practicing going through this book regularly. Okay? You can use Python to do anything. I've given you a bunch of examples. That was just the start. You can make games, you can build websites, you can stalk people on Twitter. All of this stuff is available to you if you learn a little bit more Python and use the libraries that are available to you, the modules that are available to you. So definitely think about, as you leave here, what you want to do with Python. Like, what do you want to do with programming? Because the world is your oyster at this point. OK, if you are not just here for the tutorials, if you're here for PyCon, a couple of recommendations. Number one, definitely attend talks. Like, you have enough background to get a ton out of a bunch of the talks that are happening. Talks are leveled, so the novice level talks, you're going to be able to understand a bunch of those. And I think they're going to be really fun. So definitely attend talks. Another thing I would recommend, if you want to continue to get a sense of what's possible with programming, check out the poster session. That's going to be a bunch of people showing off useful, cool, interesting, new stuff that they've done with Python. Very cool. The other thing I will say is you should definitely go to the opening reception. And there are some, I happen to know that there are some very cool surprises that I think will be very motivating to new programmers. So definitely check that out. Okay, so next steps at PyCon. What about after you leave PyCon? Number one, check out, if you're one of those folks who likes having other people to practice with, other people to program with to keep you going, to keep you on track, check out if you have a local user group. If you're local to here, you have like a billion user groups to choose from. And they're all super nice, friendly, love beginners, are going to be happy to get you started. If you get stuck on something, they can help you. So check out your local Python user group and see if they'll help you out. Number two, pick a project. Like, what do you actually want to do with Python? And make sure that you're building up the skill. Like, Python is a big language. There are a lot of libraries. Pick something that you want to do and work towards having the tools in your toolkit that you need to build that project. That's going to be the best motivators, having some practical application at the end of the rainbow. And then finally, programming languages are like spoken languages. They take practice, and you really do develop a fluency. Like, if you do Python enough, you will just know how, you will at the end of the day just know how to do whatever you want to do in Python. You'll say, hey, I want to build a website, and you'll just know how to do it. Like, you've developed a fluency in the language, in the syntax, and what's possible. So if it feels like your brain is really stretched after today, that's because you're working on developing fluency. That's important, and that'll happen to you. Okay? All of today's material is online. This is all of the Code Academy questions. This is a bunch of stuff. This is a link to like a directory with a bunch of stuff in it. So if you want to write these down or take a screenshot or whatever, photo, Instagram it, whatever, great. All online. I'll put this back up at the very end. If you have any questions or feedback, or you're like, Jessica, I'm stuck, I need help, or do you have a suggestion for a project or a book to read, I am so, so happy to help, okay? I love helping beginners. That's part of why I run the Boston Python user group. Don't hesitate to shoot me an email, get in touch with me. I'm happy to make recommendations. And to help you find folks in your community to be local supporters as well, okay? One final thing. So PyCon tutorials, they all have a shared tutorial survey thing that people are going to ask you to complete for every tutorial. So here is a link to the survey. And I think there are like flyers with QR codes. They really want you to fill out the survey. So please do it for them. And you can grab the URL from that page as well. So please take a survey sometime in the next couple of days, okay? And that is 100% it. So thank you so much for coming. I hope you had fun. I hope you're excited about programming in Python. I hope to see you for the rest of PyCon. And yeah, that's it. So it's lunchtime at this point. So everybody get up and let's all go to lunch together.